You know, it's wild to think about, but you are already surrounded by invisible helpers every single day.
Oh, absolutely. They're everywhere.
And today we are doing a deep dive into exactly what those helpers are. We're talking about AI agents.
Right, and I think it's important to clarify right out of the gate what we mean by that.
Yeah, because a lot of people just hear AI and they think of generic artificial intelligence, right? Like a computer doing a specific task, like unlocking your phone when it recognizes your face.
Or even just a standard chatbot. You type a question, it gives you a paragraph of text. That's a passive tool.
Exactly, but an agent is different.
Very different. The expert definition we have from our sources today says an agent is something that actually acts in an environment to achieve a goal.
Acts to achieve a goal.
Right. And there is a very specific formula for this. It goes perceives, then thinks, then acts.
Perceives, thinks, acts.
Exactly. The source material uses this great analogy. It says to think of an AI agent like a personal assistant that never sleeps.
I love that analogy. I could use one of those.
Couldn't we all? But think about a human assistant. If they are in your house, they see what's happening around them.
That's the perceiving part.
Right. Then they decide what to do about it. That's the thinking. And finally, they actually do it. They answer a ringing phone or they turn on the lights when it gets dark.
They act. They don't just tell you the room is dark. They flip the switch.
Precisely. And so our mission for this deep dive is to really look under the hood of these agents. We want to understand how they learn, how they make decisions, and why they are quickly becoming the active version of artificial intelligence.
Yeah, we are moving way beyond the chat box here. So let's get into the anatomy of an agent. How does this actually work?
Well, it all comes down to a core loop. And this loop is happening continuously, sometimes thousands of times per second.
It's thousands of times a second.
Yes. It goes observe then, think then act, and then observe again.
Right. Okay, so it's a constant feedback loop.
Exactly. And to pull off that loop, the machinery is broken down into three main parts. Let's use the smartphone weather example from the source to break it down.
Sure. I ask my phone about the weather all the time.
Right. So part one is the sensors. This is the input. This is how the agent collects data.
So for a phone, that would be the microphone hearing my voice.
Yes. Or cameras seeing images. It's whatever pulls data from the environment.
Okay, got it.
Part two is the brain. This is the processing model. It has to interpret that raw input.
So the microphone hears sounds, but the brain figures out those sounds are English words.
Right. The language model figures out, you just asked, what's the weather like? And then it goes and finds the current forecast.
Which brings us to part three.
The actuators. The output. This is turning the brain's decision into a physical or digital action.
And this is the part that always kind of surprises me. When we talk about actuators, I usually picture a robot arm in a car factory.
That is an actuator, yes.
But the source says it's also the phone's speaker physically vibrating to speak the forecast out loud, or a smart thermostat physically clicking over to change the room's temperature.
Exactly. The actuator is the mechanism that changes the environment. And the speed of this entire loop is staggering. It hears your voice, processes the intent, fetches the data, and vibrates the speaker cone in fractions of a second.
It's incredible, but for an agent to be truly useful, it can't just come pre-programmed with every single answer, right? It has to learn.
Oh, absolutely. It would be impossible to hard code every scenario.
Yeah.
So we rely on machine learning. And the sources highlight two main ways these agents learn. The first is supervised learning.
Supervised learning, this is learning from examples, right?
Yes. The easiest analogy is how you teach a child.
The cat analogy.
Right, the cat analogy.
Yeah.
You show a toddler a picture book, and you point and say, this is a cat. You show them 10 different pictures of cats.
And eventually they just know what a cat looks like.
Exactly. In the AI world, the process is similar. You gather thousands of labeled examples, you feed them to the algorithm, and then the model predicts the labels on completely new, unseen pictures.
So you train it on 1 million photos labeled cat, and then you show it a photo it's never seen before, and it says, yep, that's a cat.
You've got it. But supervised learning has limits. It's very structured. For an agent operating in the real world, you need something more dynamic. You need reinforcement learning.
Now this is the trial and error approach.
Yes. Think of it like a video game.
Okay, I play a lot of those.
So in a game, a player gets points for making good moves and loses points for making bad ones right.
Yeah, you get a high score or you get a game over screen.
Reinforcement learning works the exact same way. The agent takes an action in its environment. It then receives a reward.
Positive or negative.
Exactly. And based on that reward, it updates its policy so it can get more positive rewards next time. It's learning by doing.
That's wild. So it just figures it out through sheer repetition?
Millions of repetitions.
Yeah.
And here is the crucial part. This is continuous improvement. Agents keep learning even after they are deployed.
Really? So the agent on my phone is still learning right now?
Yes. From new user queries from new situations, it's very similar to how a human improves with practice. The more it does a task, the more refined its policy becomes.
Okay, so we have an agent that can perceive its environment, it can act, and it can learn. But how does it actually decide what to do in the moment? Because the decision-making process seems like it could go wrong really fast.
It definitely can. And that's why the architecture of decision-making has evolved so much. We basically have a spectrum moving from strict rules to something resembling intuition.
Let's start with the strict rules, the old school method.
Right. Rule-based systems.
Yeah.
These are essentially just simple if-then statements.
Like the thermostat again? If the temperature goes above 78 degrees, turn on the AC.
Perfect example. It's incredibly safe because it's completely predictable. It will never randomly decide to heat your house to 100 degrees.
Right.
But it's also very rigid. If you open a window and a hot breeze blows right onto the thermostat, it turns the AC on even if the rest of the house is freezing. It doesn't understand context.
So it's safe, but not very smart.
Exactly. To get smart, we move to statistical and neural networks. This is where models learn patterns instead of following strict, hard-coded rules.
Our sources use the Netflix example for this.
Yes, the collaborative filtering model. Netflix doesn't have a rule that says, if user watches Batman, then recommend Superman.
Because maybe I only watch Batman because I like the director, not because I like superheroes.
Exactly. Instead, the neural network looks at your entire history. It finds thousands of other users with similar tastes, and it predicts what you'll like based on what they liked. It's finding hidden patterns.
That feels a lot more like intuition.
It is. But you wouldn't want pure intuition running something dangerous.
Definitely not. I don't want a neural network guessing what to do with heavy machinery.
Which is why the most advanced agents today use hybrid approaches. They are the best of both worlds.
This self-driving car is the perfect example here.
It really is. Think about the inputs for a self-driving car. It has cameras, LiDAR, GPS. It's pulling in massive amounts of raw data.
And so the brain is split, right?
Yes. The perception part uses those intuitive neural networks. It needs them to identify a pedestrian stepping off a curb or a faded lane marker in the rain.
You can't write a simple if-then rule for what a human looks like in the rain.
Exactly. But once the neural network perceives the pedestrian, the action part relies on hard-coded if-then rules for safety.
Like never exceed the speed limit or always brake for pedestrians.
Yes. The car is not allowed to use intuition to decide whether to stop for a person. It just stops. The hybrid approach gives you the flexibility of a neural network with the safety guarantees of a rule-based system.
Okay, that makes a lot of sense. So we've built this amazing machine. It learns, it decides, it acts. Now we need to ask the big question. So what? Why does this matter to you, the listener, in your daily life?
It matters because the benefits are massive. We're talking about a complete paradigm shift in convenience, but also deep personalization. Agents that discover new music or movies for you perfectly tailored to your shifting moods.
What about safety?
That's a huge one. Autonomous systems simply react faster than humans. We mentioned self-driving cars. An agent can initiate collision avoidance braking before a human driver even registers the danger.
It's the perceive, think, act loop running at thousands of times a second.
Exactly. And then there's scalability. A human customer service rep can only help one person at a time. One chatbot agent can serve millions of people simultaneously across the globe.
That is powerful. But we have to look at the dark side of this too. Because you give software the ability to act on its own, and things can go wrong.
Very wrong. The risks and challenges are significant.
The first one that jumps out from the research is bias.
Yes. Because remember, agents learn from examples.
Yeah.
Supervised learning.
Right, the cat pictures?
Well, what if you are training an agent to review job applications and the historical data you feed it is full of human prejudices?
It's going to learn those prejudices.
It will internalize them as patterns. And suddenly you have an AI agent making unfair recommendations at scale, denying loans or discarding resumes based on bias criteria.
And because it's a neural network, we might not even know it's doing it, which brings up the black box problem.
Right. Transparency is a massive hurdle. These complex models are essentially black boxes. We feed data in and we get a decision out.
But we don't know why it made that specific decision.
Exactly. If a bank's agent denies your mortgage, you have a right to know why. But the engineers might not be able to tell you. The model is too complex to easily explain its own logic.
That is terrifying. Just trusting a machine that can't explain itself.
Which leads right into the next danger, reliance.
Over-trusting the agents.
Yes. We get so used to the convenience that we lose our human vigilance.
Like people falling asleep at the wheel of a self-driving car.
Or a doctor blindly trusting an AI's medical diagnosis without double-checking the scans. When agents are right 99% of the time, humans tend to stop paying attention.
And that 1% error can be fatal.
It can. And finally, we have to mention privacy. For these agents to be highly personalized, they need your personal data.
They need to read my emails, track my location, monitor my habits.
Yes. And gathering all that data into central servers raises massive concerns about misuse, hacking, and surveillance.
Okay, so the risks are real. Bias, transparency, reliance, and privacy. Given all of that, where is this technology heading? What is the road ahead?
The sources outline a few major future trends. The first is natural interaction.
Getting away from stiff prompts.
Right. Agents are getting better at understanding emotion and context. Instead of typing a rigid command, you will just be able to say, "I'm really tired." Suggest a short, funny video.
And it will understand the nuance of you being tired.
Exactly. Another huge trend is collaborative agents.
Like agents talking to other agents.
Yes. Your device is working in sync. Your home hub agent notices you are leaving the house, so it tells your car agent to turn on the heat, and it tells your phone agent to pull up the navigation.
A whole team of invisible helpers coordinating my life.
And to address those privacy concerns we talked about, the industry is moving toward edge AI.
Edge AI, what does the edge mean in this context?
It means the processing happens locally directly on the device. No cloud servers.
Oh, so the agent lives on my phone.
Exactly. The data never leave your device. It's much faster because there is no network lag, and it's infinitely more private.
That sounds like a great solution.
It is. And finally, researchers are pushing hard for explainable AI.
Trying to open up that black box.
Right. Building models that can actually print out a logical, human-readable explanation of why they made a specific choice.
Like saying, I denied this loan because the debt-to-income ratio exceeded 30%.
Exactly. Real accountability.
So to recap everything we've covered today, AI agents are essentially software or robots that follow that core loop. They perceive their environment, they think about what it means, and they physically or digitally act to achieve a goal.
Right. Ranging from simple rule-based thermostats to highly complex hybrid self-driving cars.
They learn through examples and trial and error, and they are poised to automate the repetitive tasks in our lives, freeing us up for more creative work.
But we have to remember, they lack true consciousness.
Right, they aren't thinking like us.
Not at all. They are mimicking patterns. Extremely advanced patterns, but still just patterns.
And that leaves us with a pretty provocative thought to close on today.
It does. It goes back to that idea of reliance.
Yeah. As these agents become more collaborative and integrated into our edge devices, as we rely on them for everything from driving to scheduling our days, at what point does the assistant become the director of our daily lives?
It's a subtle shift. At first, it just suggests a meeting time. Then it starts declining meetings it thinks you won't like.
And suddenly, you are living your life according to the algorithm's preferences. The source explicitly says these systems require human vigilance, but you really have to ask yourself, are you ready to maintain that vigilance every single day?
Are we ready to be the co-pilots when the autopilot is so comfortable?
Exactly. Something to chew on the next time you ask your phone to do you a favor.
A great question to end on.
Thanks for joining us for this deep dive into AI agents. We will catch you next time. Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.